Request Mr. Sriram Rajamani to come to the stage. A quick intro. Sriram is MD, Microsoft Research India, and a PhD in UCB. I'll let him, catch all the eyeballs. I would request all of you to bear with us 10-15 minutes more. In fact, a good little team has come here to give you all the demo. Thank you, Sriram.
Okay, thank you very much. I guess this is on. You can hear me? Yeah. So I realize I'm standing between you and lunch, so I'll try and make this as enjoyable and as productive as I possibly can. So I have the privilege of leading Microsoft research in Bangalore. Our office is at Level Road. And we do research in various topics, ranging from theory and algorithms to artificial intelligence and machine learning to systems, programming languages, networking, security, privacy. And we have a very interesting group called Technologies for Emerging Markets that studies the role of technology in socio-economic development. But today I will talk about work that is happening in our lab in the area of machine learning and artificial intelligence. And I'll start with this picture that it's already happening. Some people call it the invisible revolution, where we have every device is sending signals these days. Be it your refrigerator or your phone or your car or your TV, it's all just constantly sensing what's happening in your environment, and it's sending those signals to the internet, where machine learning algorithms are trying to understand what's happening to them and give guidance, control them, have feedback loops on them, and this is already happening. But an interesting phenomenon in all of these systems is that today, if you look, most of the machine learning and most of the intelligence actually happens in the cloud, right? These devices themselves have processing capability. For example, if you look at an ARM Cortex M0, which is actually one of the smaller devices, and I hope that the graphic tells you how small when it's compared to a golf ball. That one has around 2 kilobyte RAM and 32 kilobyte read-only flash. Nobody today dares to run a machine learning algorithm on that device, because no one knows how to actually run a machine learning algorithm on that device, right? So essentially what you do is that people usually use these as sensors, and they transmit information, and all of the intelligence happens in DNNs and convolutional neural networks, and all of those things are actually in the cloud. Now, why is this limiting? Imagine now that you are in a farm somewhere. You would not have internet connectivity. And you have, these things are very cheap. You can actually buy these for $5, right? Then how can you have intelligence in your sensors? What if you can actually make machine learning algorithms run on these devices? What can you do? Now, we have built a suite of algorithms that can actually run machine learning on this small devices, on the order of 4 kilobytes, 32 kilobytes, and so on. And if you can actually run, today I want to contrast between the big brain and the little brain. You can still make use of the big brain that is in the cloud, where you have unlimited capacity, elasticity, you have everything. But if you can also make use of the little brain, then you can do several interesting things. For example, you can have intelligence in scenarios where there is poor connectivity to the cloud. I already mentioned that. Another thing you can do is actually there are certain conditions under which people are sort of icky about sending all the data to the cloud. What if the data just stays in the device and the intelligence happens in the device? Then my privacy is protected better. And I think this is going to be more and more important going forward. And there are other things, like for example, just communicating consumes a lot of power, right? Imagine that your device is actually battery powered in an area in which there is no immediate, like say it's in a farm, but you're not going to run a power supply throughout the length and breadth of your farm. So not communicating makes these devices to be more battery efficient, and they can just run for days together because they don't have to spend energy communicating. So now I'm going to attempt something risky. I'm going to try a live demo. I have my colleague Shishir, whom I want to invite. So he's going to talk about this thing, which is an intelligent device. And the scenario is obviously for a visually impaired person. So without any further ado, I'll give it to Shishir. Yeah.
Am I audible? I don't think so. Yeah. Good afternoon, guys. So let's imagine a scenario, right? I'm walking down MG Road. I have a briefcase in one hand and the cane on the other hand. I've just booked a cab, and the driver's trying to reach me, trying to figure out where should he pick me up. Now, I'm a visually impaired person. I can't see. And as you can clearly see, both of my hands are occupied. I can't access my phone, right? And keeping your bag or your cane on MG Road is not the wisest thing to do. I think you guys will agree on that, right? So now, what we have tried to do is that we have built, let me just place this back to the side. Yeah, now we have built a plug and play interface. Now this small thing over here consists of an accelerometer, a gyroscope, and an Arduino class microcontroller. That's it, right? And we have plugged this onto the stick. Like I said, it's a plug and play interface. So you can imagine even a bamboo stick, we can plug it right on. Now using this cane, we have designed a few machine learning algorithms. And these algorithms enable a class of gesture recognition. Now using these gestures, you can control any smart device that you want. Today for this particular demo, I'll try and control my phone using the stick, right? So I'll just increase the volume so you guys can hear it as well. Yeah, I place it back in. And now just look at how simple and natural gestures that I do, like a double tap.
The time is 13 hours, 3 minutes, and 40 seconds.
You can see that, right? So, I mean, you can think of multiple constraint scenarios. If I'm sitting in a meeting and I want to know what the time is, I just look at my watch. But what about a visually impaired person? He has to take out his phone and use a voiceover. Now, this becomes disturbing to the speaker, and it's also quite abstract. I mean, it's absurd, right? I mean, they are not very comfortable. So you could use this. A person could just, like tap his twist and get to know what the time is. He has a earpiece in his ears. Now I can also show you how you can, like scroll through your notifications. Again, using simple gestures like a right twist.
You have 5 notifications. Notification from Outlook Calendar, NASSCOM keynote scheduled today.
Right, and I can cycle through all the notifications.
Text from Satya, is the demo finally working?
Looks like it is, right?
Notification from phone, missed call by Pratik.
Now you can see how, like subtle these gestures are.
Notification from Outlook, you have 2 new emails.
Right.
Text from wife, get groceries on the way home.
And that's for Sriram.
End of your notifications.
Now suppose you haven't heard, you can always cycle back as well. I do this, I was doing right twist, now I do a left twist.
Notification from Outlook, you have 2 new emails.
You can see that, right? So again, I think this kind of drives the point that using a cane and this small device, you can run an entire machine learning prediction stack on this. So what does this even mean? What it means is that you can now implement these algorithms on these small devices, and you can plug this on any device that you want. You can plug it on your, like on your chair. You can detect if a person is in the right posture or not. We have that in our lab actually, and you can put it on your bag or on this cane or any device that you could think of. You can just go and plug this over there. And most importantly, these gestures, you could map it to recognize whatever activity that you want. We empower you to train these gestures. And at this stage, we have an open source release wherein all these algorithms are there available online. So we encourage the maker community and the developer community to actually go there, try out, and you could come up with more compelling scenarios than we have right over here. I hope I didn't take much of your time, Sriram. Back to you.
Thank you. Thank you so much, Shishir. Yeah. I think I realize it's quite risky to do something like this, and these guys were up last night making this thing work. So thank you so much, Shishir, Don, and the entire team for making this happen. Okay. So, continuing on, right? I think I'll talk more broadly, what the opportunities we have in this space. But I'll tell you a few more applications, in addition to the visually impaired application that Shishir pointed out. This is a picture that my colleagues, we have labs in the US and so on. This is I'll skip through this one because this is just a backup in case the demo didn't work. Yeah. So this is a picture that people show me. My colleagues in the US show me every time I go there. There's a picture of a nice self-driving car which drives by itself. Has sensors and everything. And I always remind them, this is our current situation. And it's going to be a while before these cars actually are driving themselves. But then I think it's quite interesting to ask, even in this situation, can artificial intelligence and machine learning actually help with traffic, transportation, and so on? And I think we can. And I'll show you ideas we have on how AI and ML can actually help us even deal with chaotic traffic like what we have in our country. And the main thing that we're going to focus on is actually safety. Right? Safety is such a huge health hazard in our country, right? In our country, in addition to having serious health crises like cardiovascular disease and diabetes and so on because of lifestyle changes, health hazards due to road accidents are just huge in India, right? You should just talk to any doctor who will tell you how huge it is, right? And so the question that we asked ourselves is actually, can we use AI and machine learning to improve safety? Even if we assume there's a manual driver, there is a driver who's driving. the car is not self-driving, but we're going to use AI and ML to actually help improve safety of the whole situation, right? So what we're going to do is that, and we experimented this with a fleet of cars that we have in our lab. So there's about 30 or 40 cars that pick up employees every day from home to our office and then back. And we were wondering, can we use artificial intelligence and machine learning to monitor and improve the safety of this fleet? So what we have done is that these are existing cars, not self-driving ones. So we just added a smartphone and an OBD sensor. The OBD sensor is already there in all these cars. And the smartphone has two cameras, one that faces the driver and one that faces the road. And just a video is collected, and machine learning algorithms are going to run on the phone and on the cloud to sort of understand what's actually happening inside the car, right? So what can we do with it? We can actually detect so many things, right? We can detect that a driver is on the phone. We can detect that a driver is fatigued, right? I mean, I learned a lot about our transport fleet that I never knew based on this project. Because actually a lot of drivers work multiple jobs, right? They have an 8-hour shift, and safety demands that you actually give them rest. But these people are so much in poverty, they just finish an 8-hour shift somewhere else and then they come work here, right? And fatigue, people wearing seat belt and so on, right? So let me show you how all of this works together. So now this is I hope this video runs now. Can maybe someone click on this, I think, so that this video keeps running? Just click, yeah. Just click anywhere, I think, or maybe here. Yeah, at the bottom, yeah. Right, so this is actually, as they figured it out, right? So this is actually a dashboard. So this is what our system gives on a fleet, right? So what this is doing is that it's actually these videos are being collected, both the ones that, I thought that demo was risky. I thought this should work. Okay, so can you just maybe restart it? Yeah. Yeah. So what we do is actually we take these video streams that actually both watch the driver as well as the traffic. And then a bunch of computer vision algorithms and machine learning algorithms are run in order to detect various kinds of events, like driver using a phone. And we can actually correlate what we see together with the OBD sensors that tell us about speed, braking. We can actually, there's accelerometer. So we can actually also we can correlate both those information, and then we can actually build interesting things. Hopefully this now runs. I think all you have to do is to just click on that. Anywhere on the page. I think if you click, it should just work, I think. How do I do this? Oh, but this went back. Okay, let me just do this. I think you have, okay, so maybe we'll try one last time and then we'll give up on this and keep moving. Yeah, all you have to do is just click that, I think, yeah. Oh. Go back one more time and then try. I think anywhere it should just work, I think. Oh my God. I think click on the thing, it should just work. Okay, so actually if it doesn't, right, let me just tell you what this does, right? So, leave it, don't worry about it, right? So what I'm going to show is that what these algorithms do is that they give you a dashboard where you can actually click on any car, right? You can click on any of these cars. At the top row, you see various cars, and then what you also have is that we have various events. These red events and those blue events and so on are places where I think the machine learning algorithm has discovered something interesting, like the driver is actually talking on the phone, or the driver is sleepy, he's yawning, and so on, and that's what these algorithms detect, right? And it's okay even if it doesn't run, right? So as a result, right, what you can now do is that as a programmer, I can now write a SQL query, which actually says, tell me the number of minutes a driver was on the phone when he was driving, right? I could do that. I could actually say, how many times was there a close shave and the driver was also sleepy? I can actually write another query to do that, right? Now I can do that not only for my car fleet, right? If we want right to information in this country, I can now mandate that BMTC has to do this, right? But as citizens, we care for the safety of our roads. We can make sure that if any trucking company that runs these big trucks will have to be accountable to us, right? We can actually say that any citizen should be able to say, what's the safety record of your drivers? And how are they driving? Are they talking on the phone? What are they doing, right? That's the power that these kinds of algorithms can do, right? Okay. as soon as I can get the slide back, I can keep continuing. I think I need serious AI ML for projection systems, I think, yeah. Okay, we could go to the next project after this. Yeah, let's just keep going. Okay, so actually, a previous speaker also spoke about agriculture. We have another project in our lab where we are actually trying to have, again, sensors from farms and then having intelligent machine learning algorithms that process the signals and try and help with decision making there. It just so turns out that this project we also run in the lab in the US and in the lab in India. And the lab in the US, they use drones, and they also spread the entire farm with sensors. And when we looked at it, we thought that it's going to be difficult. First of all, drones are illegal in India as of today. And even if they are going to be very expensive. I mean, the farms that we have are actually smaller in our country, so cost is going to be a concern. And I actually, my dad is an agriculture officer, and I've lived in villages, and I know that if you put sensors in the farms, the next day morning you come, there'll be no sensor. It'll just disappear. That's the first thing that's going to happen, right? So what we decided to do was that we designed a helium balloon, and I'll show you how the balloon looks, with a smartphone mount that is tethered. And then we also have a sensor pod that this guy can carry. So we sort of think about, a person who has this balloon, and he has a pod, and he now has a job. We can give a name for this job description. Maybe he is the farm analyst. I don't know, something. His job is to walk around the entire farm with this. And we can see unsuspecting interns who didn't know what they were up to. We make them walk around in farms with balloons. None of the videos are playing. If this video would play, you could see that this is a person who's actually taking this farm. Can we try if this video works? Yeah. Okay, don't worry about it, right? So if you can actually, there's several videos, right? If you guys can figure out at least one of the future videos, if you can play, it'll be quite useful, right? So what happens is that, there's an app that the person has. It guides the person where to walk so that they can get an aerial view of the entire farm, right? That's, if you've seen the video, that's what you would see, right? And then these are the various images that this app takes. And then the computer vision algorithms can automatically stitch them together to form a panorama. And then the algorithms can run and then tell you things like heat maps. It can tell you, if you have a limited amount of water, it can actually give you guidance on actually where to irrigate. It can actually, it can tell you about temperature, it can tell you about pests, and all these kinds of things, as you can imagine, right? So I'll talk about one more topic, which is natural language processing. I mean, these days, we sort of talk about hello Cortana, or hello Alexa, and hello Siri, and most of these voice assistants, and voice is actually a really empowering thing because, among other things, I think it makes computing inclusive. I mean, even if you don't have textual literacy, if the computer is actually able to speak with you, I think it's enormously empowering because it actually enables people who have never used a computer before to actually use a computer. But as we know, these things actually work mostly only in English these days. They work actually not only in English, mostly in American English, right? So in fact, actually we know this because to make Cortana work, there's a separate project called How to Make Cortana Work in Indian English. And we all know what Indian English is. Yeah. But one interesting thing that we noticed is that if you look at actually linguistic usage of all of us, right? My mother tongue is Tamil. I'm going to mix Tamil and English when I speak, right? People mix Hindi and English. And this is not just anecdotal. You actually can look at all the social media, be it Facebook, Twitter, and look at actually how people use text. Most of them mix English with their local language. It's very, very common. And none of these AI programs can actually understand any of that, right? So as you can imagine, right, if these AI programs are going to be natural to people, they have to talk to us in the way that we find natural. They have to be talked in a way that we talk to each other, right? So this is actually, the second one is Kannada and English, and you can actually, I can give you a quiz on what the other ones are. You can figure it out yourself, right? But we have actually a project where we can actually look at this kind of text and make a computer understand that. Let me see now whether our AV people can figure out the next video. Otherwise, I'll talk through the next video, even if it doesn't run. So what we do is actually we have these tools which actually detect which language you're talking. or which mixture of languages that you're talking. And then, we have a bunch of NLP tools that do various things like recognize what you're talking about. They can actually synthesize speech in such a way that the computer talks back to you. All of that is possible. Let's try this now. If it were to work, right, what this video would show you is a language detector where you can actually type your sentence, and the sentence can be a mixed language text, like what you saw in the previous slide. And then the system automatically detects which parts of it are in which language, and then they will help you do translation and other kinds of things. And you can actually try it. You can actually take a mixed language text and put it in your favorite translator of choice in the web. And you will find that today that none of them work very well, right? So actually, as a result of this, actually, we can now have computers talk in languages that we are familiar with, right? So let me just now keep going. And if this demo were to work, then the same thing we can actually do for speech. I can actually speak in Hindi and English together, and we can have our computers recognize which part of what I'm talking about is Hindi and which part of what I'm talking about is English, right? Can we at least try this, see if this works? All of these are videos, yeah. Just click on that, it should work. I don't know, okay, let's just keep going, right? So, I can show you these offline. If you can meet me after this, right? So I think I want to conclude by talking about a few things, right? I find this whole opportunities in AI to be very, very relevant for a country like us. Because I think India offers an environment where there are very unique requirements in terms of cost, scale, connectivity, language, right? And AI has applications in so many domains, right? And domains that people care about, ranging from e-commerce to finance to agriculture to road safety to healthcare and so on. And there's a real opportunity we have to build solutions that are inspired by the constraints that our country has, right? And someone told me that if something can work in India, it can work anywhere, right? So I think that's actually a huge opportunity before us. And one of the other things I find is that, the sort of the math that is needed to make these things work is actually not that hard, right? I can tell you that because actually I myself was not trained in machine learning. My training was in programming languages, and I picked up machine learning in the past maybe 3 or 4 years. It's actually not very hard, right? What you need is actually you need basic calculus. You need to know partial differential equations. You need matrices. You need to know eigenvectors. If you paid attention in your undergrad, you have all the background that is needed to do machine learning, right? And most of the applied math people in India can actually do machine learning. It's not very hard, right? And not only that, actually, I find there are, even other than the top institutions, right? People send me emails, sir, I am somewhere, and I have taken, Coursera machine learning course. It's just so much available for people, and there's a lot of enthusiastic people that are around that can actually do these kinds of things, right? And we are a country with 1 billion people, right? And the other thing is that, you don't really need to buy machines or buy GPUs and all these other kinds of things. All these things are available for you to experiment with, and you can actually use frameworks and so on and do the kinds of things, right? Be it recognize tomatoes or you probably need more specialized algorithms to do good performance, right? But you can actually get going rather quickly, right? And so I also want to say that we conduct several summer schools, most of them at the Indian Institute of Science. We had a summer school in 2016 on Internet of Things, 2015 on machine learning. We just had one on artificial social intelligence. Just last couple of weeks ago, we had one on artificial intelligence and social good. And so we try and actually bring people together to get these kinds of things going in the community. And this is my last slide. We are going to have a summer workshop on the Internet of Things in 2018. And this is going to be at IISc. And we are going to have experts from all over the world giving lectures on machine learning, hardware, systems issues. And we are looking participation from students as well as startups. Usually we haven't invited startups. This time we are thinking of inviting startups. There'll be a competitive selection process, and you have to apply. And there's a review committee that will look and select the most qualified candidates and watch the space. And that's all I have. Next time I come, I'll make sure the videos work. Yeah. Thank you very much. Yeah.